Have you ever asked yourself how your phone can detect and outline your face while taking a selfie? Well, selfies are a great example of machine learning. Machine learning is the ability to train your computer to learn and maintain a specific knowledge, without the need to teach it again. This training of machines exposes them to structured information called big data, that they could use to learn patterns, trends, and associations. This learned information helps them make decisions without an explicit human intervention. As an application of machine learning, computers have been trained to sound more like humans. For example, Google Assistant, Siri, and Alexa. In this video, we utilized a type of machine learning called computer text-to-speech. This machine learning synthesizes text input we provided to produce a human speech. This speech synthesis is also a great application of machine learning. As a result of machine learning, your phone has been trained to recognize faces, with the help of artificial neural networks that imitate our brain's neurons. When you give these networks a series of pictures of faces, it learns, like our brain. The next time you show it a face, the machine will flag it as a positively recognized face. However, given that this process of teaching machines is still ongoing, the performance of these machines is still not yet at a desirable level as it should. This creates a kind of bias which is systematic and a repeatable error in a computer system that creates unfair outcomes. For instance, the face recognition feature has not been fully adopted into full use. This is due to the fact that some user groups have not yet been catered for, when the computer is doing the training. In this case, the computer may fail to recognize the person fully, hence the lack of full reliability. Image identification in artificial neural networks versus the human brain. Consider the following pictures. Pay attention to what our brain would see versus what the computer sees. This is a cup of coffee. A computer will see numbers between 0 to 1, because it is a black and white. This looks like a sleeping baby. A computer will see numbers of various ranges, because this is a colored image. This is a person's face. A computer will see this image as numbers of various ranges. These computer-enabled devices recognize, and even draw an outline on our faces efficiently, through a type of machine learning called convolutional neural network, CNN. A convolution is a process where a network tries to identify a series of images by referring to what it has learned in the past. CNN depends on an organization which imitates the human brain's connectivity pattern called the CNN architecture. This architecture is one of the major building blocks of a CNN. Different architectures have been designed to help classify different types of data. Therefore, the performance of a CNN depends on the choice of architecture. For instance, if you have an architecture that has been trained to learn images of dogs and cats, you can only use this architecture to classify dogs and cats. Otherwise, your accuracy will be very low. Consider the numbers of this face image, as seen by the computer. Please pay attention to how smaller the numbers are, along the outline of the face, and where facial features are, like around the nose, eyes, mouth and ears. The goal of a CNN is to detect the outline of the face, and the features of the face. So how does it do it? This is achieved by extracting these smaller numbers along the edges and facial features, to allow face and its features detection. In particular, when we give a computer this image, it sees these numbers. This is called the input layer of a CNN. From the input layer, CNN will extract the face outline and features by reducing the size of the numbers in the input layer. In this example, extracting minimum values around the numbers in the input layer will help in extracting face outline and its features. This process is repeated in the convolution layer, and the end result is that CNN would learn facial features like the eye, nose, ears, and mouth. The last layer is the output layer, which has now learned the facial features, and is able to positively identify the face, with an outline. In a convolutional neural network, the network learns specific image characteristics, which the computer will use to counter-check with, when applying the learned knowledge. Hence, in selfies, the CNN is initially trained to recognize faces by training on several faces. This knowledge is retained and the next time it will see a face, It activates the learned features to produce the output as a face, hence face detection. In summary, computers have been trained to think without the exclusive support of human beings. This ability is based on the different neurons that these computers have, which resemble our brain's neuron structure. With this ability, the computers have been able to make a difference between a pathway and a driveway, hence the self-driving cars such as Tesla. For the computers to gain this ability, they have been trained to learn to differentiate various scenarios. In other words, even though machine learning has accomplished a lot, it depends on what we teach it to perform. Therefore, we have to be careful to teach it the right thing so it can inclusively work for us and not against us.